Hello students, let's study today the transmission and distribution subject in that module 2, that is transmission line parameters. So first let's understand, hope you already know what you mean by transmission line and what are the transmission line parameters, because it is very basic thing. What the transmission line parameters are nothing but the parameters of the conductor or the electric circuit, whatever it is. So when it comes to the power system or the electrical engineering or electrical circuit, so the major parameters which play a very important role in all the working is the resistance, capacitance and the inductance. So here also actually in this course, that is in transmission line parameters, we are going to study so what are the different transmission parameters we have in the power system, and how do we define them. And actually the major concentration is on deriving the resistance, capacitance and inductance of a transmission line. So now the basic thing here is to understand, we already know that the transmission line, if we say transmission line, the transmission line is not something which is very short and through which we can transfer the power. It is very complex thing to understand actually the resistance, inductance and capacitance involving in the transmission lines, because the transmission lines we already know they are divided into the short transmission line, medium transmission line and the long transmission lines, depending on their voltage levels or the power transmitting capability. So that is how when it comes to the medium transmission line and the long transmission lines, it is very difficult to calculate the resistance, inductance and the capacitance of the transmission line, since the long transmission lines are laid for very long distance in terms of thousands of kilometers. So hence it is very important to note here how actually we are trying to derive the different transmission line parameters. So here we study the very basic things about the transmission line parameters. That is, let's start with the notes here. You can just go through it. So transmission line has the resistance, inductance and capacitance which is uniformly distributed along the whole length of the line. Here we should note that so resistance, inductance and the capacitance, they are distributed along the whole length of the transmission line. That is why I told already it is very difficult to analyze or to calculate the total resistance, inductance and capacitance of the transmission line. So let's understand what you mean by resistance. This we already know, that is, it is the opposition offered by the line conductors to the flow of current through it. This we already know, the resistance already in the basic electrical engineering itself we study what do you mean by resistance and what is the importance of it, how does it behaves, what is this property and what is the law of resistance. Everything we have studied, but still just we'll recall the things what we have studied already. So this is about the resistance and the inductance. So inductance also we know, that is whenever an alternating current flows through the conductor, a changing flux will be set up in the conductor, in the line conductor. Due to these flux linkages, the conductor possess inductance given by L equal to phi by I. So phi by I Henry, this is already the standard formula what we have for the inductance, L equal to flux divided by the current flowing through the line conductor. So where, see, they have given where the phi or the xi, whatever you can consider, but the phi is the flux linkage in Weber turn, I is the current in amperes. So that is the inductance. Again in the magnetic circuits, we have already studied this in the basic electrical engineering again. So whenever there is a flux linkage, that is whenever we have a coil, whenever the current is made to flow through that coil or a conductor, the magnetic field is produced around it, and hence because of the magnetic flux linkage it possesses again inductance, whether it is a resistance, inductance or the capacitance, all are the properties here. We have to note here, those are nothing but the properties. That is, we cannot see them with the eye. That is, definitely we can see the nature of all these line parameters, that is your resistance, inductance, capacitance. The effect can be We can measure, definitely we can measure resistance, inductance and the capacitance, but they are the property of a material. So which is the material here? We are studying it with respect to the transmission line. Hence resistance, inductance and the capacitance of the transmission line we are concentrating upon. So similarly, the capacitance, the very basic nature of the capacitance we already know when we say that the capacitance is existing. So usually whenever we have two terminals or 2 points which are lying at different potential, there exists the capacitance. So here with respect to transmission lines, we already know that whenever we are transmitting the power, depending on the single phase and three phase transmission of the power, we use either two lines or the three lines. So that is what, with respect to transmission line, the capacitance can be defined as so the capacitance can be defined as, with respect to transmission lines, two conductors of the overhead transmission line are separated by, over which acts as an insulator. That is, what is the meaning of this? We know that during the transmission of the power over the overhead lines, we are using the different transmission lines there. For example, if you consider the two transmission lines which are laid parallelly for the transmission of the power, so in that is, there will be a certain distance in between two transmission lines. So in between two transmission lines, air acts as an insulator. Now air acts as an insulator, or the medium which is separated by some medium which is nothing but a air. So there exists the capacitance between these two transmission line conductors. That is what they have given. Therefore capacitance exists between any two overhead lines. It may be any two. So that is, if we use 3, the capacitance may exist from 1 to 2, between 1 to 2 and 2 to 3, like that. Okay. So capacitance is given by value. The basic formula for the capacitance is C equal to Q divided by V farads, where Q is the charge, V is the potential difference between conductors in volts. This we already know. Then in order to simplify the analysis, the parameters of the line are considered as being lumped together over a certain distance. What do you mean by that? So as I have discussed already, the especially medium transmission and long transmission lines, since they are laid thousands of hundreds or thousands of kilometers together, it is very difficult to analyze, or it is very difficult to calculate the total resistance, inductance and the capacitance. Hence what we do is, in this analysis of the transmission lines, we consider these parameters are lumped for a particular distance. That means, consider if we have the transmission line of 100 kilometer length, consider 100 kilometer length transmission line if we have. So that transmission line can be divided into the number of short distances. So we go on analyzing only the transmission line of that part. If it is divided into some 10 different parts, consider. So there, for each part we try to calculate the resistance. So that is how, when we get the total values of resistance, capacitance, inductance for all the distances, if we club them together, then we are going to get the total resistance, capacitance and the inductance of the whole transmission. This is how the transmission lines are analyzed for the line parameters. And that is what is the meaning of lumping of the thing. Okay, so next part is, I think, just a second, that is what they have given. Okay, the parameters in the line are, see, present due to two different current flows, that is current flowing through the conductor. The second one, the leakage current flowing between the conductors and the ground. Okay, then the most important factor of power loss in the transmission line is the resistance of the line. This we already know. Because of the resistance, there will be a loss in the transmission line. That loss we call it as I square R loss, or the heat dissipation. Because of the resistance, whenever a current flows through the conductor, because of the resistance offered by that conductor, there will be a loss of power in terms of heat. So that is called as heat dissipation or the power loss. Hence this resistance of the transmission line plays very important role in transmitting the power, because we naturally can understand that whenever if the resistance of the transmission line is more, naturally the power loss will be more. Hence the required amount of power, or the exact amount of power which is being sent from the sending end, will not be received at the receiving end. So that is the meaning of it. Hence we have to concentrate more on this resistance. So we already know that is the law of resistance. It is given by R equal to rho L by A, where rho is the resistivity of the transmission line, and L is the length of the conductor, and A is the area of cross section of the conductor. So here if you observe, see, R is directly proportional to length of the conductor. Length of the conductor means, you just imagine, since the transmission lines are very long, that is especially for long distance transmission line, that is long transmission line or medium transmission line, the resistance will be naturally high. Okay, so it is again becomes a very important task to manage this resistance of the transmission line. So this will be taken care of before the transmission lines are manufactured. Okay, so these are all about the very basic things. What we have discussed till now is only about the transmission line parameters and their importance in the transmission line. Thank you so much.